There we are. All right, so here's the Desmos part of the video. I'm going to learn how to do all of this together so I don't have to do two different videos. Next one, I'm going to try not having two different videos, just doing it together and like figuring it out. I know I can do this. Technology. All right. So for the first one with the rectangular prism, what I want you to type in here is the equation x squared 15 subtract 2x. And then when I look at that equation, look here at the graph. I'm looking at the vertex. Now we do have a vertex at 0. I don't want any negative values. And I also see here at like 7, not quite 7.5 or whatever it is. But I'm looking for the vertex up here. Now I could change the values of the scale, but this one doesn't seem like it's like too outlandish to actually get to the vertex. So there it is. And so I get 5 and 125 as my answer. So what does that mean if it's 5 and 125? So there's my vertex. So now what does that help me with? So at 5 and 125, the x value is what the x value is this part of the tubing. So the square part, what the length should be. If I wanted to find the y value, I could plug it in here, and 15 take away 10, the other one would also be 5. It would actually be a cube to maximize the volume. But this is the big one I was looking for. So it says, find the dimensions of the container that hold the maximum amount of volume. So I can tell that, and it's in meters. So if I have 5 meters by 5 meters, and I said if you plug in here to find the y value, so plug in 5, so 15 take away 10, so that means all lengths would be 5, 5 by 5 by 5, it's a cube. That would maximize the volume. And the maximum volume would be 125 meters cubed. Now about the second part here. So on the second part, we're going to change the equation to that and see what the answer is. So let's go back to Desmos. I'm going to type that in. So I want the square root of 3. I'm going to move my cursor over and then the divide sign over 4x squared. And then inside here is 20 minus 2x. All right. I can already see where that vertex point is. It's right here. And so now the question is, what x value would give you the answer that you're looking for, the maximum amount of volume? So in this case, the x value, I'm going to write it down here, 6.667. I should just round it, 6.7, and 128.3 or 128. So let's go back. So 6.667 or 128.3. What did we find? So if the equilateral triangle, if each side is about 6.7, it gives you a volume of 128. That would be the maximum volume. So again, it says, what's the maximum volume the container can be used? So the maximum volume is 128.3 meters cubed when x equals 6.7. And so now you found the maximum volume for a triangular prism. What do you notice about these two values, 128.3 and 125? Which one gave you the greater volume, the cube or square prism or the triangular prism? And you can see that the triangular prism gave you just a little bit more. So if you went back to the other video and press play, you'd recognize this sentence that says, what advice would you give? And you'd say, the triangular prism gives you a greater volume than a square prism using 60 meters of metal tubing. That's advice. So use a triangular prism. There it is, Mr. G Math over and out. I am so going to try to use the screen casting thing and not have multiple videos so I can do it all at once and have the courage to use this technology. Thank you for your patience. Mr. G Math, till next time.